All right, in this final video focusing on proofs for this chapter, we're going to take basically the last two videos worth, and the last two videos focused on if we had parallel lines, then what sort of mathematical relationships do we have with our special kinds of angles? And in the previous video, we talked about if we had those special mathematical connections, what does that then tell us about the lines, aka that they are now officially parallel? And so now we're going to kind of jump back and forth between knowing we have parallel lines and wanting to know that we have parallel lines. All right? So the first two proofs we're going to look at, we've already looked at these, but we're going to look at them in a little different way. So this goes back 2 videos ago when we first really started talking about proofs with our parallel lines. And so this was the alternate interior angles theorem proof. This was back at theorem 3.1 that said if you have parallel lines, then prove that alternate interior angles are congruent. So when we did this, we used corresponding angles, and the corresponding angle helped bring our alternate interior angles together. But now we're going to look at this in a slightly different way, in a little bit more challenging way, just to get you to see proofs that can be done really in more than one way. And so I've got a restriction. What I'm going to call a restriction is that we're going to do this proof now, but we're not going to use corresponding angles. So first off, it'd be good if we had our given. So let's start off. We've got parallel lines. And we needed to prove that alternate interior angles are congruent. So let's get some angles in here. Let's get an angle 1 and an angle 2 that are alternate interior. And remember, we can either put them here and here, or we could put them here and there. And does it matter which one we pick? No, it doesn't matter. I'm going to go with these two. So those are the angles that I need to prove are really congruent or equal to each other. So that is my incomplete connection. I know these angles have a name, but I don't know yet. That's what I'm trying to prove, is that these angles have a mathematical connection. So this would be my dotted, let's make that look better, dotted or incomplete connection, okay? So it's not a solid connection because we don't have a mathematical relationship between it yet. That's what we're trying to get to. So there's my dotted or dashed connection. So now I need to find a helper angle. And remember, usually I would say, well, let's find a corresponding angle. But the restriction in this problem is you can't use corresponding angles. So we got to find a different kind of angle to connect to, and let's just pick on angle 1. So let's find an angle that can connect to angle 1 that's not a corresponding angle. And so we can't put an angle 3 down here because that would be corresponding. And really in the end we won't be able to connect angle 2 to a corresponding angle. So we're kind of out of luck right here as well. All right. So is there some other route that we could go here? And honestly, I would say we could potentially use that as a connection. We wouldn't just be able to connect that angle directly to angle 2 because that would be a corresponding connection. So I will kind of backtrack here because I could say, well, angles 1 and 3 are vertical to each other, and that's okay to talk about. And then maybe I put an angle 4 right here that's straight angle postulate with angle 3. So solid connection, and then I can connect angle 4 to angle 2 because they're same side interior. So I'm not going to say that I can't use this angle, because I can. I just can't directly connect it to angle 2 because then I'd be breaking my restriction. Okay? And that's really kind of the order that, we potentially could go in there. Is we could use a vertical angle, and then we could use a straight angle postulate, and then we could use the same side interior angle connection. Really, there's going to be lots of different ways, you could go about this. And so again, you just kind of have to explore, puzzle pieces here and figure out which puzzle pieces go together and how could you keep connecting puzzle pieces until you have kind of a logical full puzzle at this point. So I tell you what, I'm going to do something similar, but a little bit different than what I had just kind of presented there. I'm going to put angle 3 right here instead. Okay, I'm going to put angle 3 right there. And I know that angles 1 and 3, solid connection, straight angle postulate. They're going to add up to be 180 degrees. Now, can I connect this angle 3 to angle 2? And angle 3 and angle 2, they just don't have a special name. So I can't connect 3 with 2 yet. But could I connect 3 to another angle, an angle 4 somewhere, that could connect to angle 2? And so I will say, putting angle 4 here, there is another straight angle postulate connection here, but then I'd have a corresponding connection, and that's not allowed for this particular problem. So maybe I don't want to put angle 4 there. Could I put angle 4 here? And yeah, I could. There would be a vertical angle connection, and then I have a same side interior angle connection. And then I could do the proof this way. But let me go back one more time. Another angle that I could look at is the alternate exterior to angle 3. I could put angle 4 down here, and then there's a solid connection, alternate exterior, and then 2 with 4 connect by the straight angle postulate. And so again, I've made a full circuit here, right? I started at angle 1, I went to angle 3, solid connection to angle 4, solid connection to angle 2, and then there is my almost complete connection, and through all of those I could then have this connection between angles 1 and 2. So I just kind of showed you like 3 different setups that you could do there. And so I'm going to go ahead and use kind of the second setup. That I'm going to use the straight angle postulate. So there's a solid connection. And then I'm going to go vertical. And I know vertical angles are always congruent. And then angle 4 and angle 2, I know that they're going to be a solid connection because they're same side interior angles, and I'm in the presence of parallel lines, so I know that there's something special mathematically about those. And so again, starting at angle 1, I'm going to connect to angle 3, connect to angle 4, and connect to angle 2. And in the end, I should have 1 connecting all the way through 3 and 4 to finally get to angle 2. And again, 1 and 2 were my alternate interior angles. All right, so first, I'll start with angle 1. I'm going to start with one of my incomplete connection angles. I'm just going to pick on one, and I'm going to work my way around through all of the solid connections. So again, 1 and 3, we could go ahead and say that angle 1 plus angle 3 equals 180 degrees by the straight angle postulate. And I'm going to put a little check mark next to angles 1 and 3 because I know I've talked about it in my proof. All right? And then I'm going to keep working my way down the road here. So now 3 to 4. What was so special about 3 and 4? 3 and 4 were vertical angles. And by the vertical angles theorem, we know that vertical angles are equal to each other. And so I put a little check mark between 3 and 4. Now, here's where I would personally recommend kind of pausing and saying, once I get 2 back-to-back pieces, solid connections written in my proof, now it's time for some substitution to kick in. And to me, I think this is always going to be the easiest way to do this, instead of doing all of the substitutions at the very, very end. I will have some students do all the substitutions at the end, and it's completely up to you, but I would rather do it in a little step-by-step process. So again, we talked about 1 with 3. Here was 1 with 3. We just talked about 3 with 4. Here's 3 with 4. And so now we're going to take those 2 pieces and we're going to come up with a new piece of information that cuts out the middleman. So out of angles 1, 3, and 4, who's the middleman? Angle 3 is the middleman. So it's now time for angle 3 to back out of this problem. And then we'll have angle 1 connected to angle 4. So if angles 1 and 3 add up to be 180, and angle 3 is equal to angle 4, remember we're trying to get rid of angle 3, and 3 is that only common connector between these 2 problems, right? So what we're going to do is we're going to get rid of this angle 3, and we're going to substitute it out with an angle 4. So now we're going to have angle 1 plus, and then again, we substituted out this angle 3 for an angle 4. And so now there's a connection between angle 1 and angle 4. We know they add up to be 180. And you might have went, yeah, couldn't we have done that from the get-go? I mean, look at angles 1 and 4. There's the straight angle postulate, Mr. G. Couldn't we have done that? And you know what? We could have. That would have made our proof a little shorter. But I'm just trying to show you how some of you all will think in doing these proofs. Some of you might do extra steps than are really needed. And is it okay to do extra steps than what you really need to do? Yeah, it's fine. It's absolutely fine. All right. So now, we said that was with substitution. All right, so now let's go back to our picture and let's look at the next solid connection down the road here, and that's with 4 and 2. So what was so special about angles 4 and 2? They were same side interior angles. Now, what does the same side interior angles theorem specifically state? And it says if lines are parallel, hey, guess what we were given? Parallel lines. Cool. Proceed, same side interior angle theorem. What must now be concluded? Then same side interior angles are supplementary. And some of you are going to jump the line here, jump the gun at the start line here, and you're going to go, oh, well, that means they add up to be 180. No, it means that they're supplementary. You have to start with that. So first, I got to state that angle 2 and angle 4 are supplementary by the same side interior angles theorem. And then we get to make that little baby step. Well, what does it mean that they're supplementary? Well, it means that they add up to equal 180 degrees by definition of supplementary. And so now it's time for round 2 of substitution, because originally I connected 1 with 4 with that last round, but now it's time for 4 and 2 to come together. And so now between 1, 4, and 2, who's the middleman? You can see right here, angle 4 is the middleman. So now we're going to take, grab my highlighter again, we're going to take this new substitution piece, this 1 and 4 equal 180, and this 2 and 4 add up to be 180, and we need to bring them together. Now the thing is, we're not going to be able to right now get rid of angle 4. We're going to get really, really close here, though. Okay? And what I notice is that out of these two equations that I highlighted in pink, that they both equal 180. So what we can say is that angle 1 and angle 4 equal, but we're not going to write 180. What else is 180 equivalent to? 180 is equivalent to angle 2 plus angle 4. Now, you can either call that a substitution step, or you may call it a transitive step. Completely up to you. You don't have to write both. You just pick one, whatever one makes the most sense to you. And now if we used one more property, we could get rid of that angle 4, because it's on both sides of the equation. So if I subtracted angle 4 from both sides, using the good old subtraction property of equality, now I'm left with angle 1 and angle 2. And remember, angle 1 and angle 2 was the incomplete connection that we needed to show had a mathematical connection there. And we've now shown that in our proof. So we are officially done. So again, this proof that I just did here was a little bit longer than what it really needed to be, right? Because I made some extra connections. I went straight angle, vertical, and really I could have just automatically connected angle 1, and really if I had written angle 3 right here, that would have made it an even shorter proof. All right. So again, I kind of, it wasn't that extra, too many extra steps in here, just 2 extra steps. But I just wanted to show you what occasionally can happen. Sometimes you guys are going to write your proofs a little bit longer than they need to be, and that's absolutely fine. All right. This was a proof that we looked at in the previous video, the proof of the converse of the same side interior angles theorem, which stated that if same side interior angles are supplementary, then we've got parallel lines. But how did we prove that in the previous video? We used corresponding angles. And guess what? I'm throwing a restriction on here. This time we're going to do it without corresponding angles, which means we're going to have to find some other type of angle to work with. So, number one, let's get some same side interior angles present in our picture here. I'm going to go angles 1 and 2. Let's go over the right side. And so I would also say here, between angles 1 and 2, we know their same side interior. Is it a solid or incomplete connection? And typically, if for problems like this, we go, well, it's the incomplete connection. But we know we are given a mathematical relationship between these two angles. They are supplementary. So technically, these are already a solid connection here. And so am I given, instead of saying same side interior angles, I'm going to give them their names, angles 1 and 2. So angle 1 and angle 2 are supplementary. Given. All right, so now let's see. We're going to have to make a baby step in our proof. But before we get to that baby step of what supplementary means, let's go ahead and work on our game plan for how everything's going to connect together over here. So we need to find an angle 3 to work with, but it can't be a corresponding angle. Okay, so angle 1, I can't use this angle down here to then connect to angle 2. I mean, 2 and 3, this 3 would have a connection with 2 by the straight angle postulate, but 1 and 3 corresponding, and it's just not going to work. So I'll tell you what, we're going to do this one in an efficient way. And by that, I'm saying I'm going to put angle 3 right here. Okay, so 1 and 3, alternate interior angles, right? So we got a special name here between 1 and 3. 2 and 3, we've got the straight angle postulate. Now, between 1 and 3 and 2 and 3, one of those has to be the incomplete connection. So which one is the incomplete connection? And it's going to be between 1 and 3. And you might go, but they're alternate interior angles. That's true, they are alternate interior angles, but I only know mathematically that alternate interior angles are congruent, that they're equal to each other, if I have parallel lines. And what am I trying to prove? I need to prove that I have parallel lines. I don't know I have them right now. Now, 2 and 3 straight angle postulate, that's always going to work regardless if you have parallel lines or not. So here's my game plan. So 1 is connected to 2, and that's what I'm already starting to work on my given, right? So let's go ahead and talk about that. 1 and 2, let's make that little baby step. Angle 1 plus angle 2 officially equals 180 by definition of supplementary. All right, so check mark there. And now what was our other solid connection? With 2 and 3. And what's so special about 2 and 3? Well, 2 and 3 add up to equal 180 by the straight angle postulate. Now, keep in mind, the straight angle postulate does not use the word supplementary. But isn't it true that angles 2 and 3 are supplementary? Yes, but the straight angle postulate does not use that vocabulary word. So you don't have to tell me that 2 and 3 are supplementary by the straight angle postulate, because that's not what the straight angle postulate tells me. It automatically just says, yeah, they all add up to be 180. Go for it. So there's 2 and 3. So I'm going to put a check mark between 2 and 3, since I've talked about it in my proof. And now we've got those two back-to-back solid connections written about. So now it's time for the middleman to go away. And again, who's the middleman? Technically now the middleman is angle 2, right? Angle 2 is our middleman. So now I got to look at my two pieces of information here. These two things are going to be able to combine together, and somehow through substitution or the transitive property, we need to combine these together. And ideally get rid of angle 2. But we're not going to fully be able to get rid of angle 2 initially. So I notice both of these are equal to 180 and 180. So that tells me that angle 1 plus angle 2 is equal to, I'm not going to write 180, I'm going to write what else 180 is equivalent to, which is angle 2 with angle 3. And so again, substitution or transitive property of equality, you pick which one makes the most sense to you, because either one of them applies here. And again, we need to get rid of that angle 2. We couldn't get rid of it right now, but we can in the next step, right? We can use that good old subtraction property of equality. Subtract angle 2 on both sides. And then 1 and 3, remember, that was my incomplete connection that I had up here. But I'm not done. My goal wasn't to show that angles 1 and 3 were equal to each other. My goal is to prove that I have parallel lines. So now this is where I got to do one more step. So what I just showed was that alternate interior angles, angles 1 and 3, in my picture here, I just showed that that alternate interior angles are in fact equal to each other. And so if alternate interior angles are equal, then what must be true? we must be in the presence of parallel lines. For what reason? If you're proving that lines are parallel, it's always going to start off converse of. Converse of what type of angles did we just get done talking about, making a mathematical connection? By the converse of the alternate interior angles theorem. And we're done. So a little bit different. This one was a little bit shorter than the last one. I went for the most efficient route on this one. But again, you could have went completely differently. I've seen students go, all right, solid connection there. Let's go, let's go straight angle postulate here, and then let's go vertical there, and then let's connect to angle 1. We could have done that, and it would have taken a little bit longer, but it's okay. There's always going to be a handful of ways to do a proof correctly. Now, I would recommend trying to find the most efficient way, but if you come up with a way that takes an extra step or 2 or 3 or 8, that's fine. It works. All right, the last one we're going to do together, because the very, very last one is for you guys to try out. All right, so this one, we are ramping it up here. Look at how many lines we've got going on. We've got lines A and B, and we got lines C and D, and then we got these angles that are already marked here for us, angles 1 and 2. Interesting. So let's see, what does the given tell us? Given tells us that, hey, 1 and 2, even though they don't have a special name, right, they almost kind of look like they're alternate exterior, except angle 1 is on this transversal, and angle 2 is on this transversal. So they're not really alternate exterior. They'd have to be on one common transversal. But we know that there's a solid connection between them right now. So connect them together. And how do we know that they are equal to each other? It's given to us. I wouldn't have known that. They gave it to us. Now we're also told that we are in the presence of some lines that are parallel, C and D. So what I'm going to do is I'm going to highlight C and D green, meaning they're good to go. They are known to be parallel. Now what we are trying to prove in this problem is that the other set of lines, A and B, we need to show that they're parallel. So I can't assume anything about lines A and B. I'm just going to go from the get-go and go, I can't say that they're parallel. I need to show they're parallel. So that means in the end, we're going to be using some sort of converse of statement. And here's kind of a nice thing. Do you notice any restrictions on this proof? Did I say you can't use corresponding angles? And you're going to go, oh, he didn't. We can use corresponding angles. So hey, maybe we try to use corresponding angles. So let's start with angle 1, just for starting with angle 1's sake here. And let's talk about corresponding angles and see if we can make some connections here. Now, technically, there are 2 different corresponding angles to angle 1. There's this angle down here that's corresponding to 1. And then also this angle is corresponding to angle 1. But one of those is a solid connection because we can say that those are equal corresponding angles. And the other corresponding angle, I would have to say, is an incomplete connection because they're based on lines that aren't known to be parallel. Which one's which? And so this angle down here, I'm going to call this angle 3 officially. Angles 1 and 3, they're using transversal A, which just happens to be one of the not known parallel lines, right? But really angle 1 and angle 3 are using known parallel lines. So if those lines are parallel, we know these corresponding angles are congruent by the corresponding angles postulate. So now let's see. 3 and 2, do they have a special name, or do we have to come up with a 4th angle? And if you look at it, maybe tilt your head to the left sideways, you can see the angles 3 and 2, they do have a special name. They are alternate exterior angles. Now, can we say that they are congruent alternate exterior angles? And that would be a stretch because angles 2 and 3 are using lines A and B. And the only way that 2 and 3 are equal to each other is if the lines are known to be parallel, and we don't. So this is our incomplete connection. We need to connect angle 2 to angle 3. And who's going to be the middleman that's going to help us do that? Angle 1 is going to be our middleman. So let's start with the given. Angle 1 equals angle 2. C is parallel to D. Given. So technically, we can put a check mark already between angles 1 and 2. We wrote about it. It's given to us. Let's go right about the other solid connection, that 1 and 3. Remember, they were corresponding angles, and 1 and 3 were using the parallel lines C and D that were given to us. So we can go ahead and say that angle 1 equals angle 3 by the corresponding angles postulate. And let's put a check mark between 1 and 3. And then again, notice we've got 1 connected to 2 and 1 connected to 3. We've got two pieces of back-to-back solid connections mathematically. And so now it's time for that middleman, angle 1, to back out. So we're going to take that given piece and that corresponding angles postulate piece, and let's bring them together. That was a crazy squiggle bracket. So if angle 1 equals angle 2, and angle 1 also equals angle 3, well, now we can say that angle 2 is equal to angle 3. And we used either the substitution or the transitive property. You pick one. You don't have to write both. And so remember, 2 and 3, that was our incomplete connection. And oh my gosh, the third line, we've already got this incomplete connection figured out here. And we do. You know, this one really wasn't that bad in the end. But we're not done yet. Remember, what we're trying to prove is that the lines are parallel. So what we just showed, right? What we just showed was that alternate exterior angles, they really are equal here. And if alternate interior angles really are equal or congruent, then what must we be in the presence of? We must be in the presence of parallel lines A and B. By the converse of, again, converse of what type of angles? What were those incomplete connection angles that we just talked about? Alternate exterior angles theorem. And there's the proof. So again, could you have done this differently than the way I set it up? Absolutely. Could you have done this proof without using corresponding angles? Absolutely. It probably would have taken a little bit longer to do, but you know what? It's possible. So again, this, I would say, is probably the most efficient way of doing this proof. You could do them longer. It's completely up to you. So now I want you all to give this one a shot. And I will say, here's what I will do at least for you, is maybe I'll try to get you started on solid incomplete connection stuff here. Okay? So given 1 and 4 are equal to each other, you know that's a solid connection. Go ahead and connect up together there. And look at what you're trying to prove. You're trying to prove that 2 and 3 are supplementary, which means that's going to have to be your incomplete connection. And so now you got to think, how can 1 and 4 be able to connect up to 2 and 3? Well, do 3 and 4 have a special name? 3 and 4 do have a special name, right? And you know what? Given these lines are parallel, then yeah, there's going to be a solid connection you can talk about here. And what about 1 and 2 over here? Can we connect them? Do they have a special name? And they do. And they're in the presence of parallel lines. So there's going to be a solid connection to talk about there. And so there's your game plan already kind of set up for you. We've got 1, 2, 3 solid connections that we're going to have to connect all together using the substitution property, or maybe even the transitive property. And in the end, you're going to have to show that there is this mathematical relationship between angles 2 and 3. And guess what you're going to have to show is true about 2 and 3? Not that they're supplementary, but first you're going to have to show mathematically that they add up to be 180. And what's it mean if two angles add up to be 180? Then you're at the last line of your proof. And that is all for this video.